big numbers make us nervous? A little bit still? Should they? No, you know the steps. Remember, as long as you do the steps, as long as you remember the steps, you can do these problems with any numbers. Don't be scared of big numbers. Okay. Can I... Yes. Oh, I gotta remember. What can I do now? Gotta figure out how much this total is, right? 3.
You could subtract.
I could subtract from what?
Numerators.
All the what?
Numerators.
All the numerators, because my denominators are the...
Same.
Ooh! On fire. Joseph?
I was thinking that if you could put the 4 and 1 half, 1, 4, let me see that, 4, 1.
4 over 1.
Yeah, 4 over 1 if you put it up there, but I don't think you could do that.
Now, Joseph is pointing something out that's making me realize something very important. Do y'all remember that teachers are human beings? Do y'all remember that teachers make mistakes? We don't need this third fraction. Okay? Since these are in whole dollars and our answer is in whole dollars, we don't need to split these guys up. Okay? We don't need to split these guys up. Why don't I need to split up my 4? Why don't I need to split up the 4 and change it to 15ths? Can someone put it in their own words and repeat what I said? Sienna, do you know? Jana, can you help her out? Why don't we need this to be a fraction? It's already a whole number and our answer is in a whole number of dollars, right? Good, okay. So, let's talk about our common denominator. Common denominator is 15. What if I split my whole diagram into 15 equal parts? How many equal parts would be the whole?
6.
How many equal parts out of 15 would equal all that I have? Okay, look, if I have thirds, and I don't know my number, I still know that 3/3 is my number, right? 1/3, 2/3, 3/3, that's all I've got. So if I have 15 equal parts, how many parts is my whole? I'm going to divide my tape diagram into 15 parts. I want all the parts. So how many parts do I have? Just, I'm not trying to trick you guys. Keep it simple. Gianna? 15, okay? I'm not trying to trick you. Don't think you're wrong because the answer is very easy or very simple, okay? I want all my parts. I have 15 parts. I want 15 out of 15 parts, okay? Now can I subtract? Can I subtract my 15ths from this whole? Jonah's like, yeah. Why? You don't know why. That's okay. She thinks yes, but she's not sure why. Okay, anybody help her out? Why do we convert to 15? Yes, ma'am? So they can have the same denominator. So I'm calling this whole, it's my one whole, 15, 15, because I don't know what it is yet. But I know 15 over 15 gives me our common denominator. And yes, it's equal to 1, like we talked about earlier. Good. We can be clever with these, right? Anything over anything, if it's the same number, is equal to 1. Okay, so let's go ahead and subtract our 1/3. Oh, wait. Can I do minus 1/3? What do I have to write? Aiden, what do I have to write instead of 1/3?
Instead of 1/3, we could put.
What do we have to do to 1/3? We changed it to.
We changed it to 15.
1/15. We multiplied it by 5/5 and got how many 15ths, Zoe? It's right here. 5/15. So now we can subtract, right? Okay. What else do we have to subtract? Gibson, what else do I need to subtract from my whole before I have my remaining amount? 2/5. Can I write it as fifths when I'm subtracting? Ask Jocelyn. I think she might know. What do you think, Gibson? Jocelyn, you want to tell us what you learned?
Since the denominator is 15, you want on the common factor of 2/15, which is 6/15.
Okay, so we converted our fifths to 15ths because we have to have the same denominator. Good. Okay. Okay. There's two ways to do this. We're subtracting twice. We can either add these two together and subtract it from the total, or we can subtract one at a time. Raise your hand and tell me which way you want to do it and what my first step is. Wake up! Wake up! Wake up! Wake up! Come on, y'all. I know you all know how to do this, okay? Jocelyn. One at a time. Okay, Jocelyn, let's do it one at a time. So, here's our method. Our method is to subtract these two fractions from 15/15ths one at a time. When I say go, you're going to turn and talk to your neighbor and use your whiteboards to complete the subtraction. Okay? Explain to each other what you're doing as you're working, okay? How about this? Partner B by the window, raise your hand. Raise your hand like you're happy to be partner B. Thank you. Good, thank you, Ms. Perales. Okay, partner B, you're going to teach partner A how to do this. What? Remember we talked about how we learn? You hear it, you see it. You get better because you know you can do it. You really know you got something when you can teach it. So partner B, teach partner A how to subtract these fractions one at a time. Okay? Go. So talk her through it as you're working. Tell her what you're doing. Okay. Now, pretend that you can see what we're doing. Just pretend. That's okay. You're going to make it to me. So, and first subtract 6/5. Then subtract 5/5. Tell me what you're doing. I'm hearing really good conversations. They should all be good. Oh, yeah. Okay.
He has one to do one.
Okay, eyes on me in 3, 2, cap your markers. Awesome. I heard a lot of really, really good teaching. Thank you guys for going all in, okay? How have to teach them. Like, I don't know, I'm not the teacher, you are.
Okay, I'm gonna subtract 15 out of 5 kids.
15 out of 5? Or 5 out of 15?
5 out of 15 are about 10, 15.
Oh, how do you know?
Because I subtracted 5 from 15. And then we're going to subtract 10 out of 6. No, 6 out of 10, 15. Give me 4 15. Any questions? Comments or concerns?
Very good. Oh, Joseph has a question. Go ahead.
What I did, I had 15 over 15. I subtracted 5/15. I had got the wrong answer. I had did it wrong. I got 11/15. But I had subtracted 11/15, take away 6/15, and it had equal 5/15. But I had I think converted or something, and I had see how many groups of 4 can fit into 15. And I got 4/15.
Okay. Well, let me see your whiteboard. Oh, I see. I see. Joseph used a different method. He used grouping. We're not going to worry about that right now because we need to focus on this, right? Okay, that's okay. But that's right. You got the right answer, so you got the right answer. If you're, thank you, snaps for Derek. Awesome, being brave for the teachers. If you use a different method, that's on you, whatever you want to do. But if the question asks you to show how you solve with a tape diagram, you had better show me a tape diagram, right? You can check your work with any method you like. But I need to see a tape diagram if it asks for a tape diagram. Or an array if it asks for an array, right? Okay, let's move on. If I could find my... I know my shoes are squeaky, sorry. Derek, can you erase the board for us while I find my packet? Who stole my packet? Think so? No, this is a seating chart. Ah! Okay, I'll just pull it up. Did you see where I put my lesson plan? No, where I just did it.
Was it on a clipboard or no?
No. But I do have it right here. That's very strange. Here the bubble zero. Thank you for being patient. Oh, Lucas, didn't you notice there was a big old packet? Problems with answers written on them in front of me? Come on, I need you to help me out. Okay. Today we're going to talk about more non-unit fractions. Who's moaning? I don't need none of that. What's a non-unit fraction? Raise your hand when you know. What's a non-unit fraction? Juanita, what's a non-unit fraction?
It's something that's not like a unit fraction.
It's not a unit fraction. So what's a unit fraction? Unit fraction has what on top?
1.
Yes, a unit fraction has a 1 on top. So a non-unit fraction has a what on top, Michael? If it's a non-unit fraction, then it doesn't have a what on top? Look up here. So turn around. You can turn around. See up here it says a unit fraction has a 1 on top. So a non-unit fraction does not have a 1 on top. Okay? Any fraction that doesn't have a 1 on top is a non-unit fraction. Is this a unit fraction? No. Is this a unit fraction?
No.
Why not, Joseph?
Because it doesn't have a one
It doesn't have a 1 on top. Is this a non-unit fraction?
Yes, yes.
Is this a non-unit
Yes.
fraction?
Yes.
Yes, sir.
Miss, but non-unit fractions, do you have to have the same denominator?
No. No. He asks if you're dealing with non-unit fractions, does the denominator have to be the same? Not unless you're adding or subtracting. Okay, we did that in our application problem, our do now. But we're going to switch gears and do some more area models. Okay, question? Okay. Okay. Let's try 2/3 of 3/4. So yesterday we only had one non-unit fraction. Today, I need someone to read our objective for us. Can you read it loud and proud, Sienna?
I will be able to multiply non-unit fractions
By
non-unit fractions.
non-unit fractions by non-unit fractions. So how many unit fractions will I have in my multiplication sentences today, Derek? 2. Yesterday we had 1, okay? Does not change our process. Remember what we said earlier about big numbers and how we're not afraid of them? Right? Oh, no. Fake it till you make it. Okay, let's fake it till we make it. Okay, we use the same process, and once you know the process, you can do it with any numbers. Okay? How many parts do I divide this into first? Javier, how many parts should I divide this into first? 4. 4. How did you know that? Four is the denominator. Well, I also have a denominator of 3, so why not 3? How do you know which denominator to start with? Remember our logic. We had to use a little bit of logic. Ask ourselves, does our problem make sense? Jocelyn, can you remind us?
Since you want 2/3 of 3/4, it has to be 4.
We have to start with fourths. I can't take 2/3 of 3/4 if I don't have 3/4 to start with, right? So if I had drawn thirds and then said, okay, now I need to take 2/3 of, oh wait, 2/3 of 2/3? That's not my problem, right? Okay. Nyella is pointing out that I am behind a step. What should I do, Nyella? Kind of shade it in, right? Don't draw your next fraction until you've shaded what you're starting with. You're going to get confused. Shade and label. If you don't have this on your whiteboards, you should. The more practice you get, the better you get. Awesome. Lucas, join us. Okay. My second fraction. What do I do with it? What do I do with it? 2/3. Should I draw another model? Should I draw another model?
Yes.
Yeah? Yeah? Royalty says no. Bree says no. Aiden says no. Why not, Aiden?
Because you just split them up.
Yes, sir. Because you can just split them the opposite way. That way we see where the fractions overlap. That's how we find our answer. Okay. So let's split it. Am I done? Oh, so not done. Right? What part do I shade? Valerie, do you know? What part do we shade? Do you know, Faith?
2 of
Yeah, 2 of the thirds, the horizontal pieces, right? Can you come show us? Awesome, Doggy. Great. It's fine. Yeah, you can shade it. All right, she's going 1/3. Very good. 2/3. Awesome. Good to keep track of where we've drawn what. Yes, ma'am? Okay. And if I wanted to, could I shade in those fractions all the way across? Why not?
Because they're not really essential. Because it's always supposed to be 0.
Because we're only worried about right here.
Yeah.
Okay. Anybody disagree? Does anybody disagree and think it is okay to shade it all the way across horizontally? Who disagrees with Naomi? Nobody? You don't have to go all the way across, but you totally can. Because remember, what part do we need to count? Only the parts where the fractions what? Say it loud. Overlap. Only the parts where they overlap, where they're double shaded. Excellent. Okay? Show me on your fingers how many parts are double shaded. Show me on your fingers. You might need 2 hands. That's okay. Show me on your fingers how many parts are double shaded. Every single one of you can do this. I've got 95%. Lucas, show me. I can't see. Ooh, Gianna's got it. Gianna, how many are double shaded?
6.
Yes, ma'am. Out of how many total, Dalen? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, hold on. Six 12s. Do you see something really obvious that I can do next? Joe, what can I do with 6 12s? Do they have a common factor? 6 and 12? Yes, they do. What is it? What is it? Zoe, what is it? 2. Is there a bigger common factor? Well, think about it. Can I divide 6 by something and 12 by something that's the same? Hands down. When I say go, you're going to turn and talk to your partner about what the largest common factor between 6 and 12 is. Go. Just a little right now. Okay, tell her what you think the biggest common factor is. Where's your whiteboard? Get one. Girl, you walk in, you gotta get what you need. You sitting here wondering. Oh, okay. Wait for you to find it. We're going to talk about hands down, eyes on me in 3, 2, and 1. Good. My friends in this row, you guys can turn around. It's okay. You can turn around with your body if you need to. I want you to be able to see. Okay? So 6 and 12. I'm hearing a lot of common factor. Who can tell me what a common factor is? Bree, tell us what a common factor is.
A common factor is something that you can multiply, and then you can multiply to get your product.
Okay, and in a fraction, when we're trying to find a common factor between 2 numbers, what's the product we're looking for? Do you know, Faith? Okay, so she knows how to reduce it. That's great. But how do we about a common factor first, okay? I know a lot of you know the answers, and it's awesome that you're super excited about it, but let's slow down and really understand how we're getting there, right? So what's the common factor between these two numbers, and how do you know, Jocelyn?
3,
It's 3, why?
because 3 can go into 6 and 12.
Okay, so like Bree said earlier, your factors are your numbers that can equal your product up here, okay? Your denominator is one product, your numerator is another product. We're thinking of two numbers that can be multiplied by something to get both of these, okay? So let's write out our factors. Remember, factor times a factor is a product, right? Yes,
Would it be 2 times 6?
okay, so Derek says one set of factors for 6 is 2 times 6. Is that right? To get 12, there we go. One set of factors for 12 is 2 times 6. What else can we multiply together to get 12, Juanita?
You also can divide like 6.
Oh, we're not dividing. We want to multiply because we're looking at factors, Juanita, we're looking up here at factors, right? So what can I do, Nayela? 3 times 4, so I have 2 times 6, I have, that's a 2. I have 3 times 4. There's one more. It's the real simple one, Derek.
12 times 1?
12 times 1, okay? Here's all the ways I can multiply to get 12. Let's write all the ways I can multiply to get 6. Jessalyn, tell me one way.
2, no, 6 times 1.
6 times 1. Zoe, tell me another way I can get 6 from multiplying. 3 times 2. Is there another way? Is there another way, Derek?
2.
No, there's not another way. Okay, so our factors of 12 are 12, 1, 2, 6, 3, and 4. For 6, we have 6, 1, 3, and 2. What's the largest number, that we have in common between these two factors? Babe?
No.
We do have 3 and 3. We do have that in common. We do have 2 and 2. If we don't use the largest one, we'll have to do it twice.
So I want you're going to turn to your partner, looking at these two sets of numbers, which is the number that they share that is the greatest common factor. Turn and talk to your partner. Go. And bring it back in 3, 2, and 1. Give me a thumbs up if you think it's 1. If you think it's 2, 3, 4, 6, and 12. If you think it's 6, give yourself a pat on the back. Who can explain why 6? I should have more hands because I heard brilliant answers. I have 2 hands. Why is 6 the answer? Yep, I heard you say it, so I'm going to call on you. Jessalyn, share.
Because,
Loud and proud.
because 6 times 2 is 12, and then 6 times 1 equals 6. And they both have 6 and
Awesome. Yep, they are both factors to get this number or this number, and it's the greatest one that they share between the lists.
So we have 12, right? But is that a common factor? No, so it's bigger than 6, but 12 is not a factor of 6. It's only a factor of 12. You can't use that, right? So what is our greatest common factor? Say it.
6.
What's our greatest common factor?
6.
Awesome. How do we use that greatest common factor to reduce our fraction? We need to reduce our fraction. Found the greatest Common factor, Gianna, what do I do with it? What do I do with 6? Nyla, how do I simplify this fraction using 6s? Yes.
6 times 2.
I'm going to divide both parts by 6. Okay? That's what we just figured out from our common factors. From our common factors, they tell us what we can divide each number by, and it has to be the same number to get a smaller fraction or simplify, okay? So 6 divided by 6 is, say it.
1.
12 divided by 6 is
2.
Wow, lovely.
What if you got it?
Oh. Okay,
You can do multiple different ways with it.
I could? What do you mean?
Like 2 divided by 6 or 3 divided by 6. I mean 6 divided by 2 is 3.
Okay, so Faith's saying, well, they have 3 in common. They have 2 in common. Why can't we use those?
Because it takes a little bit longer.
Ah, yes, because if we reduce by 3/3, we'll have to reduce again, because it's not the greatest common factor, the largest number they have in common. Good. Okay. Let's talk about another multiplication problem. You need your whiteboards clean and your markers ready to write. Show me markers ready to write in 3, 2, up high so I can see. Awesome. Markers down. Here's our problem. I want you to use an area model on your whiteboard to solve 2/3 times 2/3. I know you can do this with multiplication. But we're going to use an area model.